The next example we're going to look at from the 2.5 homework and practice is problem number 7. F of x equals 2x squared minus 5x plus 5, all divided by x minus 2. Okay, this example is a little different from the others that we've looked at because it contains a slant or oblique asymptote. Okay, just as we did in the previous problem, I need to check to see if this problem can be factored. Okay, because I need to check to make sure there is not a hole. Okay, this time I may borrow and pay back. 2 times 5 is 10, so I have 2x squared. For borrow and pay back, I have x squared minus 5x plus 10. I'm looking for two numbers that multiply to make 10, but add up to a negative 5. So I think 2 and 5 add up to make 7. 10 and 1 add up to make 11. So that cannot be factored. Okay, so the first thing I'm going to look at are my x-intercepts. So for my x-intercepts, I set the numerator equal to 0. So x equals 2x squared minus 5x plus 5. Okay. But we just said that this cannot be factored. Okay, since it cannot be factored, I need to double check and see if I can get a value using the quadratic equation and see if it's just an irrational x value. Okay, so I have x equals plus or minus the opposite of negative 5 is 5. So we have 5 plus or minus. B squared is 25 minus 4 times a, which is 2, times c, which is 5, all divided by 2 times a, or 4. So this is 5 plus or minus. I have 25 minus 4 times 2 is 8 times 5 is 40. I'm going to get a negative number underneath the square root, so I cannot solve for x, which means there are no x-intercepts. Okay, next I need to find the y-intercepts. To find the y-intercept, we set x equal to 0 and solve for y. So in my numerator, if I plug in 0 for all of the x values, I have the constant 5 to remain. And then 0 minus 2 is negative 2. 5 divided by negative 2 is negative 2.5. So I have a y-intercept at 0, negative 2.5. Next, I'm looking for a horizontal asymptote. Okay, the degree of the numerator is 2. The degree of the denominator is 1. So the degree of the numerator is bigger. And therefore, there are no horizontal asymptotes. Now, since there are no horizontal asymptotes, we need to check to see if there is a slant asymptote. If the degree of the numerator is exactly 1 greater than the degree of the denominator, then we have a slant asymptote. And that actually occurs in this case. The degree of the numerator is 2. That's 1 greater than the degree of the denominator, which is 1. Okay? So to find the slant asymptote, we are going to use long division. So I'm going to take x minus 2 and divide that into 2x squared minus 5x plus 5. So I'm looking for the value to multiply by x to get 2x squared. I know that x times 2x is 2x squared. So I'm going to multiply both terms and get 2x squared minus 4x and subtract that from above. So 2x squared minus 2x squared is 0. Negative 5x minus negative 4x is negative 1x. And I bring down plus 5. Negative 1x plus 5. Okay, I got to multiply x by negative 1 to get negative 1x. So I have negative 1x plus 2. And when I subtract, I have a remainder of 3. Now, when we're looking at finding the slant asymptotes, we ignore the remainder. And whatever polynomial I have above, excluding the remainder, I set equal to y. And that creates your slant asymptote, which is in our case y equals 2x minus 1. Okay, there are no holes because the numerator cannot be factored. Next we have vertical asymptotes. To find vertical asymptotes, we set the denominator equal to 0 and solve. So I have x minus 2 equals 0, and a vertical asymptote is located at x equals 2. First thing I'm going to do is graph my vertical asymptote at x equals 2 with a dotted line. Next, I graph my slant asymptote. Okay, this is a line, so use the slope and y-intercept. My y-intercept is negative 1, so I'm going to go down 1 unit. And my slope is 2, so I'm going to go up 2, right 1, up 2, right 1, and we will continue finding points using the slope, both in the positive direction and in the negative direction. And we will connect those with the dotted line. When we have a slant asymptote, we will have two curves. The two curves will be across from each other, either from the left and the right, or top to bottom, and the curves will run along both the vertical asymptote and the slant asymptote. Let's go ahead and plot in our y-intercept at 0, negative 2.5, which is right here. So it looks like I need to plot a point where x is 1. Alright, so when x is 1, 1 squared times 2 is 2. Negative 5 times 1 is negative 5, plus 5. So it looks like I have a point at 2 minus 5 is negative 3, plus 5 is 2. Oh, I forgot to divide that by 1 minus 2, which is negative 1. So we have 2 divided by negative 1, which is negative 2. So I have a point at 1, negative 2. So what happens is my curve is going to come up through the point 1, negative 2, and fall back down along the vertical and slant asymptotes. Now I need 2 points to the right of the vertical asymptote, like 3 and 4. Let's start with 3. Okay, for problem number, or for the number 3, I'm going to plug it in. 3 squared is 9, times 2 is 18. Negative 5 times 3 is negative 15, plus 5. All divided by 3 minus 2 is 1. So if I simplify, I get 8 divided by 1, which is equal to 8. So I'm going to go right 3 units and up 8 units. Now for this problem, we plug in 4. See if we can get that to fit on the curve. So if I have f of 4, 4 squared is 16. 16 times 2 is 32. Negative 5 times 4 is negative 20, plus 5. All divided by 4 minus 2 is 2. So 32 minus 20 is 12, plus 5 is 17. 17 divided by 2 is 8.5. So I'm going to go right 4 and up 8.5. And this curve will also go up and run along the vertical and slant asymptote. Next, we need to find our domain. Okay, and the domain is going to be based on our vertical asymptote, because notice the curves goes down and to the left forever, and the one above goes up and to the right forever. So all values of x are included in the domain for the exception of the asymptote at 2. So my domain would be negative infinity to 2 and 2 to infinity. All right, we have now covered every type of rational function, those containing no slant asymptotes and no holes, and then those that do contain either a slant asymptote or a hole. Okay, your job is to complete the remainder of the graphs in this packet. Okay, you may skip 2 graphs. Okay, you may skip graph number 4. Okay, so problem number 4, you can skip. Okay, you may also turn and skip problem number, what was that? Oh, problem number 9. Okay, you may skip problem number 9. Good luck, and we'll go over your answers and questions next class.